Thank you all for coming and joining this presentation. To give you a small impression which industry we are in, I have a small video sequence I want to show you now.
Let our experts walk you through the nanocosmos of the atom. The complexity of manufacturing tiny transistors requires a clean room as big as 2 soccer pitches. While our people monitor the complex processes, automated manufacturing itself always takes place within hermetically sealed production lines. Our global foundries manufacturing teams must therefore take extensive precautions every time they enter our dust-free clean rooms. The result? Our wafers are fabricated in an environment that is more than 100,000 times cleaner than an operating theater. From the photolithographic stage, wafers move on to the ion implantation, where the electrical properties of the transistors will be specified. Global Foundries, the first truly global semiconductor foundry, located in the USA and Germany, Fab 1 in Dresden and the future Fab 2 in Malta, New York. Together, they'll be 2 of the most advanced chip factories on Earth and a testing ground for the very latest microelectronic innovations from around the globe.
So this is actually the industry we are working for, and so the presentation today is called Working in Big Projects. So I want to give you a brief overview of what we understand in big projects in the semiconductor industry. We have been working all around the world. The main focus of making semiconductor is currently in the US. It's a big company, it's a big country for making semiconductors. Japan, but the really key is in Taiwan and South Korea. So they are really, really strong, and they use their factories also for political reasons. So both countries are small in size, but they are all have invested in semiconductor to be protected by the bigger nations, and this is a very interesting thing, and we have been part of this development, but this also gives us some problems, so we get information later, and I will come to this later in our presentation. These are all the projects we have worked for. We are since 20 years on the market, and we have been involved in about 28 new factory startups in the high-tech industry. Our recent project in Taiwan was a big project, which you can see with these figures here. So the clean room size is 150,000 square feet, which is not too big in the industry. So the one in Malta is almost double size, but still we had to plan for about 30,000 different consumers. So supply points within the equipment, the complex equipment to operate need a lot more than an electrical plug. It needs up to 150 connections with special gases, chemicals, ultra pure water, all these very delicate things. And 30,000 data points were in our models we had to work with and to do the design for all these 32,000 data points. And to do so, we had to build up SketchUp models with in total 22 kilometers or 8.7 miles of cable trays, 35 miles in pipes and ducts. We had to plan for huge exhaust volumes, so there are big diameters in 2.5 meters or even more, and we have to design for about 671 cubic feet per minute exhaust flows. there are a lot of different gases, 62 bulk specialty gas types, all flavors from silane to hydrogen, whatever you know on gases or chemicals is in this factory. The same applies to the chemicals, and of course, if you feed in all these chemicals and gases, you have to drain and treat them with a water treatment plant. A lot of electric power goes into this plant, and this is one which is planned for 20 nanometer node size, which is really tiny and small. So a light microscope won't show you anything. And this is still not the latest technology which is currently on Earth. So looking to what we have done in this project and what is our scope, we offer 3 main fields with our team. The one is industrial engineering, and this includes the master planning, the fab building design. The simulation is part of our offer. Automation layout, you have seen all these vehicles in this small movie sequence. Equipment subfab layout, the facility utility matrix, which gives you all the totals of all the flows, so you can plan your central supplies accordingly. We are also part of facility engineering, which is a different part of the engineering in this type of factories. And a very important part of our role is space management. It's a lot about space management, and this is where really SketchUp has changed our work, how we work dramatically. We work for process lateral engineering. These are all the supply laterals you have to supply all these 30,000 supply points. We are also involved in hookup and infrastructure engineering. Hookup means once the equipment arrive in the clean room, then you have to hook up this to all these supply points. And in parallel, for managing our projects and to be very efficient, we have developed 2 different software packages. The one is SemiSoft. This is a database system which is used in the software and in the semiconductor industry for facility management and hookup design. And we also have we have developed the 3scan. Some of you may know this extension for SketchUp, and this is for 3D engineering, and this also will now have some simulation aspects. This is a slide I want to show you why we like SketchUp so much and why we have so much success with SketchUp. So our work has really fundamentally changed since we work with SketchUp, and this is the perfect tool to express ourselves and to show really our thoughts, what we have in mind to our clients. And it's really, really fast, so we can make iterations in the early project stage, and we can work live with this iteration in meetings and show what's going on. So this is what we feel every time, and if you have this billion-dollar investments, the effect is a lot. The sooner you develop or you spend all your ideas, your intelligence into a very, very good conceptual design. This chart shows here on the axis the project development by time, and in the conceptual design phase, obviously you have the biggest impact on how the factory will work at the end of the day, how the schedule will work, how the investment will work, and how the life cycle will be at the end of the day. Unfortunately, you can see in some building projects, there's not a baseline. So in Germany, we have currently one airport which has 3 years delay and billions of additional costs. So once the concept is not good, then the building goes wrong, and there's no measurement. You can't see if it's right or wrong. But the good thing is with SketchUp, we have the ability to support our clients and say, hey, we try to think about these boundaries and try to implement a lot of experience in the very beginning of the project and have a lot of impact to their success. And as you can see here, so we work with SketchUp in the conceptual design phase. We work in the basic engineering phase. And here is where we start to use SketchUp plus extensions. So we then add the extension to extend SketchUp in the later engineering phase. And once we have developed all the concepts, and we hand over to the big BIM, which is Revit or so. So these are the architects and the other companies working on this project. They take our data and remodel or work then with Revit and go through the entire phase until construction management and operation. So our field of competences here are these three first things. So we do not offer any construction management, but we do offer engineering in the first three phases of the project. On our last project, and this emphasizes one more time how important SketchUp is for us. On our last project, we had a huge data drive. So we had a cloud drive where we shared all our data, and we analyzed this cloud drive. What are the file sizes in this cloud drive? And this corresponds very well to the man hours we feel we have invested in the different software applications. So you can see we worked almost all our engineering time we spent to work in SketchUp. And the good thing is it still makes fun. So even we worked so hard and so long in SketchUp, it's still fun to work with, and this is a good thing. We have published our documents in layout, we have made our calculations in Excel, and AutoCAD is the standard for the incoming data, and it's the standard for the outgoing. So we had to work with AutoCAD, but purely only to this level. So we received files and prepared them to import them into SketchUp, and once the deliverables are complete, we converted them back to AutoCAD and sent them out to our clients. Of course, we did some presentations, some meeting minutes, and Visio we used for some schematic design. So this is really how important SketchUp is now for our work and for our workflow. And to give you some impressions how far we go with SketchUp, I have some slides showing you complex engineering results. This is a slide showing the hookup of one really complex tool with all the quarter-inch piping up to the big diameters of the exhaust. And this is one tool out of 1,000. So 1,000 tools with this complexity you have to go into a clean room within a short period of time. This is a building model which we developed together with an architectural firm. We had the responsibility to develop the functional part, and they had the role to develop the office building and all the architectural things. And with SketchUp, we were able to show three totally different building concepts of the functional parts in a very short period of time. So we developed in only 4 weeks totally different concepts, and they really appreciate our support. They then continued with Revit. They said with Revit it wouldn't have been possible to do these different concepts. This is a view showing a process lateral system. This is exactly what we have done now in our last project, and we will show you more later of this. And this is another view which show you all the different trades facilities. So cable trays, exhaust, above each other and in different levels, space, provisions for future installation. So everything is in this model. This is a view showing more detailed the laterals. So this is the big clean room, and these are all the different laterals with a good arrangement with easy access. So we puzzled a lot, and this was really, really helpful to discuss and communicate with our clients and sort out many of the problems in front of the project and try to build the thing.
So we have, how many hundreds of people worked on this?
So all these models have been prepared with our team. 5 of us prepared these models, and we started actually after Christmas, and we handed over all our deliverables with 3 major iterations end of last week.
5 people.
5 people, yes.
Sebastian, one question. You were saying you couldn't do it in Revit, you could do it in SketchUp. Why is that?
So actually, I'm not a Revit expert, but what I received from feedback from the architectural firm is that they need quite a lot of time to model the building in Revit with all the small informations they need to go in. And they are very familiar. They're working in 3D since, I think, 20 years or so. They are one of the architectural firms very advanced in Germany. And they were really impressed how fast we could make the iterations and how fast we could make iterations live in front of the client. So this was the pure benefit of the SketchUp in comparison to the Revit at this project stage. And there was an interesting thing in this project. We handed over both the architectural model for the factory, and we handed over the pipe model for all the facilities. And the architects, they totally understood the value of developing the function of the building with all the move-in paths, the clean room restrictions with the space management. And they didn't care in which format we handed over the result for them to remodel everything in Revit. In fact, they took the PDF dimension plans and they remodeled everything from scratch. And they were happy. They said, that's perfect. We don't need the model. We need the value is the function of the building. And your value, thank you very much, is that you have made this 3 iteration, including the client, in front of the client. The facility people or technical people, they asked us to give us the models in 3D, and we handed over everything in IFC, and I will show you later. So, any further question?
So for facility, we're here to kind of do some language translation too. We learned in seeing the preliminary presentation, facility is what we would call utilities throughout the building. It's not the furniture. It's all that stuff you saw, the spaghetti that you saw.
And when he's talking about tools, he's talking about machines. He's talking about 1,000 machines on the top floor, thousands on the lower levels of the building.
So, I have a question. So are you using like space parameters to auto-generate those layouts based on constraints? And
They're going to show us.
Yes. The answer is yes. Okay. Amazing.
Some of it, yes.
Yeah. What we do for this presentation now, what we have prepared, we built together a small factory. So actually the mayor from Steamboat Spring called me this morning and asked if we can have a small research development factory here in Steamboat Springs, and that's why we are here now, so that's what we do. So everything starts with a library. So by working a lot in this industry, we have built up quite some libraries for different elements, and we sort them into building facility and equipment. And this is just a very brief extract of how our libraries are organized, what we do have in our libraries. So building obviously contain all the doors, all the stairs, loading docks, elevators, and all these type of things. So we have organized this in a file. So typically we have one file which is called all elevators, and then we have all different kind of elevators with front doors, small, medium, large, everything in one file. And we just pick the elevator so we have a good understanding which kind of monument this elevator is within the building. The same applies to the facilities. So we have all kinds of space holder for facilities. We know the tanks from the tank farm or the vaporizer, the compressor from the compressed air. We have some standard sizes. So this helps us a lot to understand the functional area layout. How big do we need different areas for the different functions? And what I want to show you here live is the functional area layout, the development of the functional area layout for the equipment. So typically these equipment functions are divided in different areas like lithography, wet edge thin films, metrology, dry edge diffusion. There are more, but this could be exactly the same in any other building. So this could be a hospital, this could be a chemical factory or whatever. You have some functions, and our approach for all these buildings production building design is we really emphasize our clients, let's start not with the building and let's see what can we squeeze into the building. Let's start to give an equipment list and list up your production. That's the key. That's why you built this building for. And let's first have a good understanding how big need your building to be. And to do so, we try to make an estimate about the grid size. So in this case, we have grid size from 4.8 by 4.8 meter, and we have a good estimate about the elevation. So these three colors here should represent an area, a level, an area, a block in a level, and we want to populate now this with the equipments required by the client for this project. So for this project, you need 2 implanters. So what I do, I just copy the 2 implanters here on this space holder for the equipment, and I copy the implanters, 2 of them, and the same I do with the furnaces. This is an diffusion furnace, and the furnace I also copy in here, and let's say I think he has 21 of them. And the logic thing now is to get a good understanding how big your building need to be if you duplicate this grid space holder. So these 2 grid space holders are needed now, let's say, I don't know, 8 times. 6 times is better, huh? And with this space holder, I now have a very good understanding about the size. It's not really nice aligned, but I think you know what I mean. I have a good understanding of the size for the diffusion area. And this is a very important parameter to now design and build up my building. And the same need to be done for all the other functional areas. So at the end of the day, if you went through this exercise, and of course you need to go through this exercise also for facilities, for offices, for everything, all the functions within your building, then you get a list of how many of these elements are now required to place your equipment. And this is a very good input then to size your building.
One thing that's kind of unique, and I haven't seen too many industries like this. In the semiconductor factory, they establish the size of the structural grid because the equipment's changed throughout every factory's life. So this factory they decided was 4.3 meters. I've worked with Sebastian on a plant that was all 24 square foot precast blocks, and the whole factory was built like that. Because what happened on that job, and I know it happened on this one, is they'll change the tool list or the functional description of what they want, and they have to rearrange it, but often the factory's already built. So just
exactly.
makes more sense then.
Okay, so the first step, and this is what I wanted to show you in this planning process, the first step is to get a good understanding about your functional areas. So the result from the first exercise is to have a functional area layout with the space requirements. The next step is to understand the size and location of your site. So here in Steamboat Springs, this is our new site. And by having all these functional areas and these elevations already, you can easily then set up a component which then is a represent one of these elements, one of these cubes. And this is a good point then to duplicate these things, and then you have the first good idea how this entire building, how the number of blocks you have found out as a result in the functional areas are set on the site. So this is the first time when you have a good idea, is the site big enough? And how is the building located on my site? Is this a good location? Or do I prefer to have the function of the main function here close to the road and have a good understanding of the size of the building? And the exact same thing you do then with the other functions. So you should have a block, as mentioned before, for the building elements. We do have a block which represent the stairwell, and here for the outside function, a very brief, easy block show the air return. So in these type of factories, you need always an air return area, and then you just build your fab with the outside elements, and then you have a good understanding how this building is located on your site and what are your other elements you need for this building. Let's put in the cornerstone. So this is your facility on the side. It looks quite nice, and it's very handy to have this type of a model, because typically if you discuss with the client about this functional buildings, then they talk about aspect ratios or different locations on the site. And with these blocks, you can easily, in a live demo, cut these blocks and put it together. And in front of your client, you can work on the rough outside of the building and give them an impression how this is located on the site. The next thing is then to develop the other functions. So typically you have a CUB building, which is stand for a central utility building. And again, the good thing would be to have all these functions and have all these functional areas and play with these blocks. Put in your monuments like the elevator, have your loading dock placed, and the same do it for your other CUB building where you have the electrical and the cooling water units typically. And if you have more information already, if you have something in detail, just put it in. It makes the model nicer. And then in this case, we have a good understanding how big the tank farm need to be. We have a first rough estimate about the gas consumption, and that's why this model already contains a tank farm. And what we learned is really essential for a good function of the building is to make in a really early stage an analysis about the escape ways. So you have to go out from these type of buildings very fast in a short way. And we use triangles because obviously the equipments, all the functional areas are always rectangular organized within the factory. So if somebody wants to go out, he can't go diagonal. He has to go this and this and this. And this is, you see, everything from here to here is the same like from here to here. And with this triangle located at the stairwells, you can see they overlap, so we are in compliance with the escape way, maximum escape way here in Steamboat Springs. And once we have done this triangle analysis, you can then add the other elements. And the good thing is with the SketchUp model built up so simple here, this is a good point in time to work with the client and give this first model to the client, send an email, say, here's the result of our meeting. And this is really the beauty of SketchUp. You don't have to write long emails and long meeting minutes and say, oh, our conclusion was this width and this length of the building. You just send the model, you put some dimensions on, and they can play themselves with the model. They get confidence that the meeting or the results, all the discussions are fruitful, and they really support this approach. In the next step, very, very important then, is to make an analysis of the building, of the elevation, of the sizes in terms of space management. So we learned that, especially in these high complex buildings, all is about space management. So if your shafts and if your areas for huge pipes are not big enough, you have a difficult project. So everything will run very, very difficult. You have to find spaces, bubbles here, and it's not lean and clean anymore. If you have good space management from the very beginning, then it will be a good project. And to do so, it's the best thing to just look up at this model and try to understand which area of this building is presumably the most complex area. And in this model, I would say this is a difficult area. You have here the stairwell right on the edge. You have another bridge going into this building here. So a lot happened here. And you combine the most complex equipment with this area, And then you start to model your space management. And this is exactly what we have done here. So this is this edge. And I'm running through the space management approach. Unfortunately, we do not have the time here to go from scratch and develop this from scratch. But what you do, you first develop these blocks with real elements. So in this case, it's a steel fab. So you build up your beams for the first level. You have a slab on the first level. Then you add your beams for your second level. You add a slab for this level. This needs to be a little bit more stiff because the equipments are located here. Raised metal for pedestals, some tiles. And then you can start already to model in this small edge of the clean room or of the building everything including the clean room. The clean room needs to be supported from above, so you have to have an interstitial with the steel structure. You can add some more details like the stairs from the previous model. You can add some people, which makes it nicer. You will add some equipment here in this model. AMHS is standing for the Automated Material Handling System. This is this overhead transport system you have seen in the video before. And these equipments also need some sub-equipment to work, so they do have some pumps and chillers, local scrubbers in the sub-fab. And you also then have some space left here, which you can fill up with some support functions. You can have a lab or a workspace. And when everything, all the functional areas are within this space management model, which is a combination of all the most demanding spaces in the entire building, then you can add to put in the facilities and have a good understanding, the power, the exhaust, cooling water. So you add all the facilities just conceptual. So this is just a rough estimation about the diameter. You don't know the exact sizes, but this is a good understanding for a first estimate if your entire model is a good model or not. And again, sprinkler system, the coverage from the sprinkler. And once everything is done, then typically in this section once you explain how you build up the model in this section view, this is a perfect thing to discuss. You can measure or put some dimensions in, and then you can really adjust your heights, your width of the columns and everything in this section view in X and Y direction. You can add also to review if the elevations of the building are set up in a proper way, how the logistic would work, how the dock will then level with this fab. And once you have done all this, your end result is the structure of the building with one cube. So one cube, which is now a lot more detailed than the cube we had in the previous model, is now verified with all utilities. Everybody understood this is a reasonable cube in terms of elevations and in terms of column width. So you then easily just say save as, put it to your desktop, go back, and we are here. And again, that's why I like SketchUp a lot. Here's the factory. So this was quite fast, and because the space management is organized well in layers, and the layer do have the elevations in their layer names, you then can really go from above and go down the building and really show how the different elevations are built up. And so from top to bottom. Then if this is ready, then it makes a lot of sense to start to develop your equipment layout. So this is my clean room. I have all the raised floor tiles in the clean room. And remember, I started everything here with this functional area layout. So all I have to do now is to copy my equipments and place them in the equipment layout in the factory. So I go in here and have here my equipment. I took some of the and align these equipments then in the factory. And this is a longer work, so you have to really take care about the automation system, about the different function groups. You have to care about contamination, cross-contamination, functional areas, and so on, so on, so on. So I will show you a little bit later how we work to do this layouting process, but SketchUp is really, really helpful for this equipment layout task. So the move tool is so much faster and easier to handle than a move tool in AutoCAD. So we used to work in AutoCAD in previous projects in former times, and I couldn't catch up in AutoCAD with a meeting. And with SketchUp, I have the chance. So if somebody tell me I want to rotate all these equipments by 180 degree, then yeah, I can follow up the speed of the meeting and show them how this works. And once you have developed your entire layout, you end up with something like this. So this is a proposed layout for our factory here in Steamboat Springs. You have every functional area is represented here. You have already your tracks from your automation system, and the building model we have developed together. So this was not a big deal. Of course, to make it in a real project takes not minutes, it takes more days or weeks or months. But however, it's a very, very good tool to develop, to come to this stage, and everything is backed up by real data or information. The real world, and this is what really slows it down, the real world is, and I'm sure you know this from all of your projects, is the clients change their mind. And especially in the semiconductor industry, the processes and the technology is developed so fast. So when they decide to build a new factory, the equipments are not yet manufactured or not yet developed in some cases. So the equipment manufacturers still in Japan or whatever on the world, they continue to develop the latest techniques for the process chambers or for the auxiliary equipments. So this change all the time. It's a fluent iteration process. And this is a lot of pain in the traditional workflow. If somebody then, if you went this far and somebody come and say, hey, it's very nice, but these three equipments are replaced now by another equipment. And what we want to show you now is, you may think that we are so fast because we have all these libraries. Yes, it's true, the libraries helps us a lot. But we also realize that the libraries are good to a certain point. So you can't work in a project by only having libraries. You have to have the ability to develop new models very fast. And this is what Hans wants to show you now. Don't be afraid. If you're on your project, you have to have the ability to model any model with just a little of information from the vendor.
So that's where we'll continue. Usually we get drawings like this, just as a PDF file, or even worse, we only get bad quality JPEG files. And how we handle this, we usually make a screenshot. Save it. And import in a template we already prepared. So this template includes all machine parts that are usually in the machine. So this is the maintenance area that Sebastian mentioned already. This is a typical load port that is also based on a standard. And here we have controllers, foots, feet, wheel, and so on. So everything is in this sample file. And that's where we import our screenshot. We immediately explode the screenshot, which will lead to the screenshot being transferred to a material. We make a group, go in the material, and give this one a slight
transparency. And now we can go inside the group, pick a measure, and resize. So and now we have the correct proportion. As a next step, and this is the beauty as it's a group, we can just pick the section we want in order to have visible only what we want to see. Let me just turn this. Go to our origin. And we will also have here the origin. So these machines usually have an origin that is in a relation to this load port. So now what we can do is just do and draw this one and use the SketchUp tools and our load ports. So I will spare you watching me doing all this this machine. I will just fast forward. So this is the pure geometry of this machine. So we will just have to adjust the origin of this component. And what we will add now, based on what you saw here, we have information about the utility connections of this machine. So to be honest, this is a sample machine that is quite simple. It only has 3 connections. But I think it will show you the way we work with this. So now we use our 3-string pipe, and we'll just add the exhaust if it wants, which it doesn't. So we will just pick the appropriate size based on that utility chart, align it, and in this case it's important to give it pin outside visible in order for the connection to be visible from the outside once the machine is closed. So to make the other ones, we have to get rid of this. ¾ inch. And here in this case you see we have the scale, and you can either go on the scale, which is imperial in metric, or you can just input the value by hand, however you prefer. And now we know that this is 200 millimeters up here. Up, another one. And now we just add the connection. So what we can do now is give these connections a name. So for example, this is number 1, the PCW supply. This is connection number 2, PCW return. And number 3 is the exhaust. So the biggest problem we always face in our project is data. And by data in this relation, I mean the utility chart. I showed you this is an example of 3 utilities, but the harsh reality is usually the machines can have up to 150 different utility connections. Gases, exhaust, drain, whatever, name it, they have it. So, and we, in the past, we came up with development of the SemiSoft software, which is a separate software and a database that had all these information, all this data of the utilities inside. But as this is not really too practical, as you have an ever-changing project world, we thought hard about finding a solution. How can we put this data
in this case the utility data, in 3D. How can we marry our geometry with data? And our team came up with a really good idea and also made it become a software reality. We call it Data Cube. And in this case, a Data Cube is a visualization of a data container. I will show you in a minute. So as soon as we enter this tool, we leave the SketchUp work area. We kind of work on another plane, on another level that is on top of SketchUp. So we can still see the geometry, but this is not a transparent mode. This is the data cube level, so to speak. And in this case, we can select the data cube. So we say we have all these different utilities inside, and we will select exhaust, in this case, general exhaust. And here we can input the data that we have from the render. So in this case, we just have the flow data, and we have the pressure. So here you can change the units for both flow and pressure. And once you're done with this and you are happy with your input, you just place this data cube. It will ask you where to place it, on what component you want to assign your visual data container. And I select this tool. And now we can not only assign the data to the component, we can also assign the exact position within this component. So this is very important for us. And in this case, we will say this is the exhaust, so we go to the damper. So the damper is the exact position where we want to have this data, as you can see here. And now we will add the PCW, supply, select the tool and the position. And we do the same for the return. And now we're done. So now we can leave our data cube mode. So what did we do now? So now we have the geometry of this machine, and we also have the appropriate data of all utility connections that we work with in such a big factory, and everything is inside, ready to be used. And now I will hand over to Sebastian.
Okay, thank you, Hans. So you see,
Does that make the model heavier?
yeah, thank you for this question. So the answer on this one, we worked with the IFC data. So our initial idea was to do exactly the same thing with the IFC. Unfortunately, we learned that the IFC put an entire library to this model and it's blow up the model. And in this particular case, it's a complex system which is linked to other main data sources, which is a project data cube. So you can really, really easy exchange your data, and everything which is stored here in this model is squeezed to the very, very minimum. So we puzzled long to have only the minimum data assigned to this equipment.
I don't want to deviate too much, but the project data cube, does it reside within the SketchUp model or outside of it?
So the project data cube could be outside, so it could be accessed in one directory. All the files will get the same data cube, or you can have an individual project data cube within your one particular file, which gives you the ability to also have some variations. So you can say, if I change this facility from this flow to this flow, then you can do this for all the equipments in this model.
Can you define what those things are, or are they just limited right now to gases, chemicals?
No, we started, so our first development, which we, by the way, showed today the first time in public with the data cubes, is we started with the facilities, because we know facilities are the most complex data. Once we achieve this with the facilities, it's easy and obvious We can have the same data assigned to weights, to cost, to scheduling, so everything can be just thrown to this equipment and say, this is what this equipment comes with.
So for facilities, it's utilities.
Utilities.
Right? So what these are is conceptually, and now I just now saw why it's called a data cube, because they graphically represented a little cube. What these are is metadata blobs that you put into anything and attach to anything. But by identifying the exact location where we want the blob to be, that data can interact with other data. When you tell it, they share the same. Yeah. So it's data blobs. Is what they're talking about. No. Data cube's great.
Okay, in the meantime, I put in the new equipment at the right place. And I want to show you another tool which we use for layouting purpose, which we have developed. So when you do some layouts, it happens from time to time that you do not really align nice your equipment. So I think you know this yourself. Sometimes it's too high and it's not really nice aligned. So you make a copy, and at the end, when you're done, then you really want to have all these things aligned properly to the front side. So we have this new tool which we call Align, obviously. and with the Align tool, you then can grab one equipment which is your master, one block, one component, and then you select the master, and then you can align this to the front side, to the back side. With a toggle, you can align this to the origin of this component. And what you also can do with escape, you go back, you can rotate all them at the same time, and you can obviously also put them back to, so let's put them with only 2 clicks aligned nice here. And in addition, what it also does, it has a special sensitivity for this maintenance area. I can distribute these equipments here in a space along one axis, and if I toggle with the shift button, it will give me a minimal overlap of this maintenance area that I still in compliance with this maintenance area, and I can then align my tools, and with another toggle I only get the pure geometry of the inside bounding box, which means it ignores the maintenance area. You see this on the scale, it gives you then the 0 value, and then you can here type in also some data, and again, like the SketchUp tools, you can change your mind and say, I want to have this 200, 150, whatever. So this is the Align tool, which helps us a lot to be faster in making equipment layouts.
If you, let's say they want to replace 3 pieces of equipment with 3 that are larger, and you've got metadata associated, will it detect if there's not enough space and then bump the model and rearrange things to allow for that larger component? Right? But just a question.
No.
So you have to read it.
So if you have piping connection, those 3 elements.
Yes.
You decide you want to just do it to one side, or if you're deep piping, putting levels off of it.
If it's physically possible, yes. So of course, if you have a straight pipe and an elbow, and if you can bring it down, yes, it will also realign the pipes. Okay. I think it's your turn now.
So let me take over.
Let me just explain again. So in our model here, what happened is now, not only the equipment layout change, the data change as well. So like in a real project, somebody pop in and say, yeah, we changed our mind, this particular equipment need to have different data. And so Sebastian now want to show you how we work with data. So not only with the equipment layout, with the geometry, with all these SketchUp tools, with our own developed layer above this, we can show you what you can do with data.
Yeah, thank you. So now we have this great model, equipment model with all our iterations. We got our new models inside it, our new machine models here. And this means our whole data changed. In the past, it would have meant that following this change of geometry and change of layout, there would follow a big synchronization process with databases and checking that every data is up to date with the newest geometry and newest equipment layout. And this new approach, this building information modeling approach, makes the model the pivot point of everything. So we just have this data up to date on a mouse click, and this makes now data analysis really a game, like a computer game. It's really fun to do. So I can launch now the data cube report mode, we call it. For example, for our exhaust system or cooling water system, let's take a cooling water system, the return PCWR you already saw, and these are all the cooling water supply return points which are needed by the tools or the machines inside this area. And in the whole 3D information is inside it, and you can really see, okay, this connection over here needs everything of this cooling water. And the beauty of this is completely interactive. So you can click on these data cubes here, and the list here in this window will update interactively and show you all the data which is stored inside this container. So like the flow values, units stored, pressure values, positions, and so on and so on. And of course you can draw rectangles around it. It feels like you're used to it with the SketchUp selection tool, like you would select components, but it's completely a different layer of tool environment you're inside. So you can just select what you want from these machines, and even more, you can not only visualize the positions of the cubes, you can also visualize the quantities, like in a kind of column diagram view. And you see, okay, these three machines Hans just modeled, they have a really big return flow of cooling water. You can select it with shift select, completely natural. And these are these machines, and as we can see easily now, he put in cubic meters per hour. I probably think he did an error with the units here. So this data cube reporting mode is also a really good mode or feature to validate your data. If this would happen in a normal, like a database, maybe this error wouldn't have been so obvious. So we can play around with this, and we can also, let's say I want to mail to Hans now, hey Hans, you did an error. So I just select these three columns over here. I have to resize this a bit. And I choose export table to Excel, and it just exports my selection directly to Excel with all the data, and it can send this extract of data to Hans and let him verify his inputs. Okay, so, and the most common thing to do with factories is to view or to validate the sum of all consumptions of every utility type you have inside this factory. So you need some kind of tool to extract the whole data at once. Of course, we have this also inside this. We just make a data extract of all the raw data, and here it is. So only in this small demo fab we have like 1,800 points of connections of different utilities from from bulk gases and everything, which was already in our library. And what we do now is to use this raw data, which is not nicely formatted or something, and put it in templates, just empty Excel tables which are linked to an empty space where I can copy now my raw data inside it. And now I magically have these sums of every kind of utility I need inside this fab. So I can now mail this nicely formatted extract of sums to the facility engineer or somebody else to work with it. So this is the main power of building information modeling, because with every iteration we do and with every little change we can directly show and communicate the consequence of these changes to our customers. So where was I? Here in the if there would be a request of the client, hey, let's change the number of tools over here to double the number, then we can say easily, hey, did you think about that it doubles the sum of your process exhaust, for example, and this is very critical for your decision. Would you like to overthink this? And then we can easily communicate what the changes would mean. Okay, and so with this power of data analysis, we can now proceed to design our lateral systems, to design the utility piping around all these machines. And so I will pass again to Hans, who will show you how we work with the piping.
Okay, so now we have a top-level analysis that we can provide to the customer, who can actually work with the total consumption of all the utilities and double-check what he ordered for the machines, for the cooling machines and whatever. And what we would do now, if we go on a detail level, in this case we just check the acid exhaust as an exemplary design. So what we can do, for example, we would have the total sum of the acid exhaust, and as we already saw that this table updates everything that you select. In this case, it's like all the acid exhaust that we have in a fab. And based on what we select and what we have as a target value for the maximum velocity, in this case, which is here, 11 meters per second, this already gives us a proposal of the duct size. So in this case, it's 590 millimeters, so I would select 600. And this is like the main collector for the whole fab. But you can also go down, in this case, to the bay or lateral level, which is just what is in this grid. And I would have the same thing. I would have the total sum of my flow, and also, again, a proposal of the duct size. So in this case, I would select the 450. And to determine the size of the takeoff point, so what size of damper do I have in my duct system, I can just select one machine and it will show me I need a 200 millimeter damper for this. So with this information from our model and from the data cubes, we would go back to our space management model, and we would replace our conceptual design we had in the previous. We would just replace this duct, in this case by a detailed duct, and we want to do metric stainless steel. And I would just go to 450, which is the size we just determined. And in this case, as we have a bigger size, I have a conflict with our steelwork. So I would just adjust the orientation a little. based on what's my requirement. So in this case, I also align the conceptual because I want to replace this conceptual duct with my detail. So as time is a little pressing, I will just jump over this step of replacing everything and show you the final result of this detail duct, which would be this one. Let me just bring it up a little. Okay, so this would be one typical lateral for our acid exhaust. And to tell you a story, we have experienced in quite some projects that people say, yes, we like your design, but is it really feasible? Can you do that? So we had a meeting where it felt like a setup. So we had the client, we had a client, and we had the subcontractor of the client, and he was like already having his design laid out of the same we did, of the same utility. And the subcontractor showed us the design, obviously everything in 2D, so he was quite sure that it works, but we weren't. We had a different approach. And he was quite confident that his design is really good and ours is not. And we even had a detail situation where he said, this doesn't work. And we were really lucky because for this last project, we developed a tool for pipe duct and cable tray support, because that was the gap we always had. We do nice designs, and the client wants this to be verified, like it can be actually installed in the field, and you can only verify this if you show the pipe support. So I will just show you, give you a quick live demonstration of how this works. So this is our known steelwork tool. So we would just, again, live presentations. So this is this one. Then we would use our new tool and look for a position of this foot for the. So we call it generic, like U profile, but I guess you are quite familiar with like Unistrut, so which is a brand name, but that's why we prefer to name it like U profile. And with this U profile, you can also add this one here. And it's the same philosophy that those of you who already know 3scan tools already used to. And here we can add, for example, our fitting. And based on the geometric relation of these two U profiles, it will pre-select of what are possible to be installed in this geometric relation. So this is just this one. So, but I told you that that's pipe support, so I gotta prove this also. And let me just grab this here. So once you have a pipe in place close to a profile, you just want to click on the U profile. You select the pipe clip, and that's like a really big selection, but as I don't know which one I need, I just hover over the pipe in this case. So it will automatically select the correct size. So you would click to determine the size of the clip. The second step aligns to the X and Z axis, and the last one lets you rotate in the correct direction. So you have this one. So, but usually in reality, you not only have the situation that you want to have a connection to a U profile, to a C profile. You also want to be able to connect on a steel beam. So in this case, the same. You hover over it, you align it, determine the orientation, and now you have the clip to the steelwork. And in the end, this is just a really simplified, but you can make like complex racks like this, and you can attach and construct your pipes to that. So that's a small thing about the mount tool. But let's go back to our main goal to design our acid exhaust. And in this case, we would just select what we designed in here, go back to our layout, and in the end, just where did you go? That's awkward. Yeah. So yeah, so that's like a live presentation. So once we have laid out our lateral, in the end we will be able to give like the whole acid exhaust in this case, which will be the design of this one. And once we have determined this, what usually happens is that the customer says, we are used to bigger sizes. And for this question, we already have an answer. And this answer, Sebastian will give you.
Okay, so so really, this happened not only once to us. Factories are normally built with a big safety margin, and they cannot construct the pipe sizes so in detail like we can now with our building information modeling approach, and so we can really go to the limits of the space management and crunch as many machines as possible inside our fab. And the thing now is that we have this pipe infrastructure and want to know, does it really work? And we have already the whole flow data of the machines. So the only thing we have to do is find a way to connect the machines easily to our infrastructure and tell the system somehow where the flow should go. So this is our endpoint of the acid exhaust. It may go to some ventilator or air scrubber or something. And so I define this end of the pipe as the source. We call it the source. And I choose acid exhaust so that it's defined as an acid exhaust pipe infrastructure with a maximum flow speed of 10 to define a little bit of margins. And this source, now I can call our so-called assignment mode, which enables us to not to have construct every single hookup of every machine in detail for our piping system. So we can, with this assignment, just put these data cubes, which we defined earlier, to the 3 points of our piping infrastructure. So I put it here, I put the whole machine to this takeoff points, for example, and as you can see, maybe it was already obvious, you have a color-coded abstract visualization of your piping infrastructure. The center lines of the pipings are colored by the flow, which is calculated inside these pipes, and it recalculates itself in real time when I change the assignment of the machine interfaces. To spare some time, I just select all, press the control key for an automatic assignment algorithm. This chooses the next takeoff point, and as you can see, the whole system gets recalculated in real time and shows you directly where your problems are in this infrastructure. For example, you have quite high flow speeds here in these both laterals. This happens because the assignment, the auto assignment, just put this machine to the other one too, or to the other lateral too. So I just reassign those quickly, and so this pipe is already unloaded, and here we could think about maybe repositioning those sub-tools over here in the subfab level and optimize our loading of this pipe too. So, but the question was, the question is not about the flow speeds. We want what we want to know is the pressure loss in the pipes. So change our visualization to the pressure loss inside the pipes, and now the pressure loss is calculated depending on our pipe elements we have. For example, T pieces of pipes produce a different pressure loss, and depending from which directions the flow comes through this T piece, the pressure loss is different. And we can answer our client in this case. He doesn't have to be concerned about the system. It will work perfectly with a quite low pressure loss. The minimum point is shown here. It's 565 pascals, which is very good for this infrastructure. Yep. Okay, so this is our little pressure calculation tool, and the thing now is how to get all the thing we did now, the geometries, how to pass them on. And the most difficult thing with this is that we don't want to lose data. We don't want to lose all the effort we put into naming of the components, defining the descriptions and so on. And the current AutoCAD export from SketchUp loses all this information. And in other cases, we have too much information. So many clients have weak computers and they want to have all the data in two-dimensional drawings. So we have also for this made a small tool to I just demonstrated. We can flatten this whole 3D model, and so this doesn't destroy our components. We can still select all the components and have all our names, IDs, definitions, and so on inside it. And this kind of flattened 3D model we can now export. With a normal AutoCAD exporter, it would lose this description and name information we want to keep. So we extended and customized the exporter and used the DFX format of AutoCAD, which is the same like DWG, only in clear text, not in binary format. And we customized it so that every component gets a real AutoCAD-like block attribute-oriented definition. So I export it to our DXF. Ah, yeah, okay. So, was it there? Huh?
Oh, you have DWG, you must DXF on.
Ah, okay, sorry. Yeah, here's my file. Okay. So in this file we have real block attributes now, which are fully parameterized and can also be rearranged with the block editor, like you know it from AutoCAD. So, for example, here what vendor model configuration tool ID and so on. Everything we want to put inside the model we can put into it and make almost AutoCAD like a BIM ready or BIM connected program for our approach. Working with Revit is a bit difficult. We use for this the IFC format, and to work with the IFC we also have written some little helpers. There's my IFC demonstration here. All the piping also contains a lot of information, which type of piping, some details and so on. And we we can add this whole information, crunch it down into an IFC tree, and what SketchUp enables you to do is just to set the type, but we can attach with the SketchUp API much more information of the IFC behind this type, like dimensions, length of this piece of pipe, and so on. And now export this with a normal IFC exporter. Put it to the desktop. And open it like this. Screen resolution is so small. Open IFC file, desktop, add, upgrade it now. How long does it take? Okay. Okay. So, and what we get now is still a very coarse geometry model, which is not really in the Revit style of parameterized piping model. But if you pass this on to the Revit engineer, he can see now still working. He can see now the piping model and redraw it if he wants to, and because he has this whole IFC data in it, he can easily see what kind of pipe we intended to be there. So if you hover over this piece of pipe, we have through this IFC modeling all the data in it. So this concludes our whole workflow, how we manage a project of this size, and I hope you enjoyed it. I will pass for the last words to Sebastian, and we have still 5 minutes, not a lot, but
Good in time. Just. Okay, thank you very much, Sebastian. So for this session, what we've shown you, the main purpose was to design a small factory with you. And just to emphasize one more time, a focus on what we learned in all our projects. If the concept is right, the project is right. So spend in previous projects before we had SketchUp, all these nice tools, this concept, the concept was a sketch, and we had all the hassle in detail design. We really emphasize do detail design on a particular place in the very first beginning. This is very important. The second thing is work from inside to outside. So do not allow to build a building because it's nice on the side and then squeeze your functional areas into this building. Make sure the building is around your functions you need. This will make also your process and the operation a lot easier. So you will avoid these bubbles and this equipments on near the elevator, all these things which you don't like to have from the very first beginning. So you want to avoid that somebody enter the brand new fab and say, hey, this looks weird. And the third thing we really want to emphasize is space management, space management, space management. If you have 3D, you can really work very much in the beginning. All the shafts, all the critical zones can be worked out very much in detail, and this helps you a lot. Last but not least, I want to show you the last slide. So today we showed you quite a couple of extensions we worked with. 3scan pipe channel steelwork is available. You can download this from the extension warehouse. Today we showed you 4 more extensions which are in the pipeline. One was the mount. You remember the pipe clips and all these things which were demonstrated by Hans. Data cubes which were presented by Hans and Sebastian. We also have one thing in the pipeline, which is simulation. This allows you to do some CFD analysis. We unfortunately run out of time, but you know this computational fluid dynamics thing. So for clean rooms, for large halls with air conditioning, you can make a simulation. And last but not least, we want to combine all the tools for equipment layout with the line tool, some other tools, Revit, you can pop down all the equipment on the floor to another package. We would love to call it 3D layout, but layout is already reserved in the SketchUp world. And so, yeah, the last thing from our side is if you have any questions, raise your hands and ask all your questions. And if you would give us feedback what you like most, then this would help us. We also want to use the Basecamp to get your feedback and know where we should focus on in the development of the next extensions.
On the data cubes, can you define your variables in your data cubes? Or do you have to rely on your
So the answer on your question, maybe if not everybody heard the question, can you define the variables in the data cubes? The answer is the project data cube gives you the master data. This is your data such as the units or the velocities. And the good thing is you can have a defined project unit, but still you can put all your data in any unit in your models. So you can have an imperial unit, a metric unit, and whatever you have, it will convert everything back to your project unit. And if you change this project unit to whatever you have, instantly you have the new information. And this applies to all the source data.